Um, you're going to graph the quadratic inequality, which means it's a parabola with shading. So we're going to have something opening up and shaded, something opening down. So we're going to use our calculator to set the boundary curve. We're going to use dotted lines if it's less than or greater than. So if it would be an open or a closed circle, we use dotted. Or if it's going to be an open circle, we use dotted. If it's a closed circle, we use our solid line. And then we're going to talk about shading the appropriate region. And I think we were doing some exam review. I talked to you guys about how we can use our calculators to do some shading. So let's take a look at the first problem that we have here. We have y is less than or equal to negative x squared plus 2x plus 5. So let's get our graphic calculators out and let's type that in there. We need to make a table of values. We need to do some shading on there. So I'm going to go to y equals, and I'm going to type in negative x squared plus 2x plus 5. I like to hit graph because it gives me an idea of where in my table to start looking. Remember, you need to have that line of symmetry. And so when I hit graph, my line of symmetry looks like it's close to positive 1 or positive 2. I can also see that this parabola opens down, which matches what I see in my inequality. I have a negative a value, so my parabola should open down. So I'm going to look at my table of values. And remember, we still want to make the same table. So I want to have the vertex in the middle. So the point that doesn't repeat is the 1, 6. That's your vertex. And then I should have 2 points above and 2 points below that will show me symmetry. So I'm going to use negative 1, 2, 0, 5, 1, 6 is the vertex, and then 2, 5, and there should be a 3, 2. So those are my 5 values. We don't ask so much in this case for line of symmetry and vertex. We just want to get a sketch of this. So we're going to do negative 1, 2, 0, 5, 1, 6, and then we come down on the right-hand side with our symmetry. I want you guys to get in the habit of having your parabola fill the graph paper. Some of you guys make these little tiny things that just connect 5, which at the time was okay, but we're going to be doing some systems of inequality, quadratic inequalities, where we're going to have 2 parabolas on the same graph. So let's take this parabola, let's take this U-shaped curve all the way down. I'm going to give you guys 2 options for shading. I'm going to explain the shading to you guys and how I do it, and then the other way is to have the calculator do it for you. This says I need all the values less than this parabola. This is the highest point on the parabola. And so to be less than that parabola, I have to go down from that lowest point. And so when I go down from that lowest point, am I inside the parabola or am I outside the parabola? I'm inside the parabola, which means all of my shading is going to be inside of the parabola. So that's what it means. Greater than means you start at your vertex and you go up and then you shade there. It's not always inside or outside. I can't give you that simple of a rule. But what I can tell you is that less than is always going to go down from the vertex, and greater than will always go up from the vertex. What was my inequality? Less than. So if I'm up at 6, how do you get less than 6? Do you go up or do you go down? Down. So that's why I shaded below. And below that vertex was the inside of the parabola, so I have to shade inside. The other option that you can do, ladies and gentlemen, is on your calculator, you can take your calculator and you can force it to do a less than or a greater than. So if I go over to the side here and I get this, I make this cursor on the far right left-hand side flashing, I can hit enter and it gives you a thick line I can hit enter and it goes above, which means it's going to be greater than. I can hit below and that means less than. And so then what I can do is hit graph. And where does my calculator show me the shading is going to go? Where's the calculator show me the shading is going to go? Inside the parabola. All right, so you've got a couple options. Think about what it means, less than the vertex, and then shade that part of the parabola, either the inside or the outside that's below it, or go back to your graphing calculator. But either way, you've got to make sure you understand what this symbol here means. Keisha.
Okay, so we'll use like the thin line, right? The thin line.
I use the thin line. I don't take the time to change my calculator because every problem I have to change this. So I keep my calculator on the thin line. That's how I do it. And I hit graph. And notice once I use the thin line, my shading's gone. So the way I shade is I go back and look at this and say, okay, I need to be below the vertex. Below the vertex is right here. So that's how I do all my shading. So when you say we won't ever use the thin line, I can't tell you that because I will only use the thin line. And I can't answer your question whether we'll use it or not. It depends on which method you choose, how you choose to do your shading.
You use a thick line because it's true for okay.
No, I didn't put the thick line on the calculator.
Not the thick line, I mean like the
When I went over here, here's the thick line. This is the triangle is greater than. The triangle below is less than. So then right now in your notes, I would write down triangle below is less than, triangle above is greater than. So have something that you can look back in your notes tonight while you're working. But that's what, so that's why I don't like this method because you're having to memorize what that means. Where here, I understand what less than means. Less than means to go below. Means to go lower. All right, let's take a look at the next one. You've got to graph a system. We're going to graph a system of quadratics the same way we graphed a system of inequalities. You're going to graph one parabola, shade, graph another parabola, and shade. These are both less than. One is going to open up and one is going to open down. So that's what you're going to see is that these two parabolas, these two U's, intersect each other. So you need to go to your calculator and type in x squared plus 5x minus 6. I would hit graph just so you can start to see where that vertex is at. Now when I look at my calculator screen, what happens here is my vertex isn't actually on my graph. That vertex is below our viewing screen. So that means I'm going to have a little bit larger y value. That's going to happen tonight in some of those problems. So you're probably going to have to take your graphs and count by 2s. I don't think you'd have to count by something as large as counting by 3s. But you need to make sure that you can fit that vertex on your graph. So be prepared to count by 2s in your homework. But my vertex looks like it's back over here at like -3 or -4. So when I go to my table of values, I shouldn't be surprised right now that I don't see any repeats because I'm still over in the positive x values. I need to keep going. And what happens here, guys, is something that we haven't seen in a while. We actually don't have any repeats, okay? Which means your vertex is somewhere here in the middle. Now, the nice thing about this lesson is I'm not too picky about having the vertex there. We're not asking you to label the vertex. I'm not asking you to label the line of symmetry. So what we can do here is simply copy down those first 4 values. So we're going to copy down the -4, -10, -3, -12, -2, -12, and -1, -10. So what we need to do is figure out what that's going to look like when we graph it. So this is my blue graph. So I'm going to do -4, 1, 2, oh, I guess I need to count mine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mine's not going to fit on here, so I'm definitely going to need to count by 2s. So we're going to take, I simply write -2 on that first line. I don't need you guys to renumber that whole scale for me, because what happens is it gets crowded as you're trying to cram in -2, -4, -6, -8. I know now that you're counting by 2s. I don't have to count by 2s on my x-axis. If you want to, you can. But I'm going to go over to -4, 1, 2, 3, 4, and then -2, 4, 6, 8, 10. So this is -4, -10. I need to graph -3, -12. So I'm graphing -3. -12 is just one more down. And now I just have the repeats. I just have reflections. So -2, 12, and -1, -10. Now you need to draw a parabola for me, ladies and gentlemen. A parabola does not have a flat bottom. It always comes to a point. We don't see that point in our table. And so what you need to do is, as you connect these, you need to come in so that you slowly dip below that. I'm not going all the way down to the next point. I'm just going down a little bit below that -12. And then we're going to keep going up like we talked about, so bring it all the way up. For that graph. Now I told you guys to do your shading. Here's where the middle of my parabola is at. I need to be less than that, so I'm going to go down from that point. When I go down, am I inside the parabola or am I outside the parabola? Outside. So that means this time my shading is all on the outside. Now if you want to draw arrows, kind of like we did when we were shading graphing inequalities, you can. But notice, guys, this is kind of like the exact opposite of what happened on our first one. It was less than, but we were inside the parabola. This time we're less than, and we're outside the parabola. But I can see that if I draw my arrow for less than, I shade everything around that. You're never going to cross the sides of that parabola. So now the system of inequalities is just the same thing with the second problem. You're going to go to your calculator. What?
Can you get enter both at once in both systems?
You could. You need to make sure that you're getting the right ordered pairs for the right one.
Right.
So to me, it doesn't matter what time you take to enter them in. And the calculator should still be able to do your shading for you, because I think one shades vertically and the second one shades it sideways, so you should be able to see where they intersect. So I'm going to take -x squared plus 9. I'm going to make a table of values for that. My table of values for this second equation is going to be -2, -1, 0, 1, and 2. And this is 5, 8, 9, 8, 5. Now what you have to keep in mind, ladies and gentlemen, is these y values are all above the x-axis, but you're still counting by 2s on that x-axis. You can't switch to 2s, switch to counting by 1s. So I'm going to plot the point -2, 5, 2, 4, 5 should be right here. I'm going to plot -1, 8, 2, 4, 6, 8. 0, 9 is here in the middle. And so I'm still looking for you to plot good points. I mean, I want to make sure you guys can still plot points, still understand that when you change your scales. I need to graph my parabola, so I'm going to sketch that with connecting my points, and I'm going to go all the way down to the bottom of my graph. This is less than, so I'm going to start at the vertex and go down from the vertex for less than. This one, the shading happens to be in the middle. So I'm going to shade inside the parabola. And so what I'm looking for is the area where I have blue and black together. In here is all black. So that's going to be where the blue I'm going to follow along the outside of the blue parabola, but then stay inside the black parabola. So what you should see is this is what your darkened in region should look like. Let me try and get rid of it. That's what your darkened in region should look like. It should follow along the back side of that blue parabola, but staying inside your black one. Okay? Any questions, ladies and gentlemen? Your assignment is a book assignment tonight. You will need some graph paper. So I'll have Mr. Clemmer check and see if we have some graph paper for you guys. It's not going to erase everything.
Yeah.
I'll run and make copies of the graph paper.
Yeah.
I'm going to do that. What's your question, Ray?
What is that?
Because the table is coming by threes for some reason. It's not coming by the table set. Usually it's not by three. It's not by one. Yeah. So, but it was just because you were counting by threes instead of counting by ones.
You're welcome. Yes.
Why don't you do your grandpa's wedding?
Name what? Licorice?
Why did mine go over like here?
Because it doesn't go straight up. A parabola is a curve. So your parabola it has to curve out. It gets wider and wider and wider. None of these parabolas go straight up and down. And I guess I'm not answering your question, but it's the definition of a parabola. Yes. Hurry, please.
Yeah.